Good morning, everyone. So let's start our discussion with a prayer. So please keep quiet and mute your devices. Okay, so once again, good morning. And before anything else, I'd like you to go to this link, and this is for your attendance. So please fill in the required uh, fields. So this is it. That is for your attendance. Okay, and that is the link for your attendance. Just take a screenshot of this. Okay, let's proceed. So our main topic for today is all about electricity and magnetism. So that would be our topic for today. So I hope you're doing well. So let's proceed. Now, have you ever wondered how a simple motor works? So you know what is a simple motor? It's somewhat like in layman's term that is what we call dynamo. So most of the kids when I'm still young, I usually play with it, but I really don't know what is the physics behind how that toy works. So that is our main topic for today. So most of us, I know that knows what is a dynamo, but we really don't know how it works. So what is the physics behind it? And that is what we're going to tackle today. So from this very simple idea, this is what happens inside a dynamo turn into this. So from this very simple idea, we applied it or we tested using that uh, simple device. Then we make it a little bit higher or a little bit creative. This is the part inside the dynamo. Then we have that motor, electric motor. Then go to a generator up to this power plant. So from this very basic idea, we arrive at this. And from that, we come into this light. So how is it possible that from this basic concept of physics was able to produce all of this? So that is how that's gonna be our topic for today. We're going to understand the physics behind such phenomena. Okay, let's proceed. So for your activity, it's all about magnet and current as one. I do believe that during our previous meeting, I required you to have with you a piece of wire, a compass, and a battery, because in this activity, we're going to use that for you to be able to perform this. So please get all your materials and follow this procedure and steps. So procedure, place the compass near a conducting wire and run a current on it. Then observe carefully what happened to the compass needle as the current is turned on and off. But before that, let us have a background about what is a compass and how the compass works. Now, compass is being utilized by most of navigators. So they use it to navigate around the globe. So a compass, it has a needle on it. That needle is sensitive to the magnetic field of the Earth. Earth itself is a big magnet. So think of it that the Earth is a big magnet. So when you say magnet, it's somewhat like a magnetic field. So we have your North Pole and the South Pole. Now our compass is very sensitive to that magnetic field of the Earth. That's why it will move and points to the direction of the North Pole because the needle itself is a magnet. So since it is a magnet and the Earth is a magnetic field, so it will move whenever we move it in a very specific direction, then it will move or it will seek the North Pole of the Earth. That's how compass works. Now for this activity, you are going to make this. So again, this is our battery. So you place the battery, then we have here a conducting wire and we have a compass here. Now in your end, I want you to follow this diagram. So the battery is here, then we have here just a piece of wire. Anything will do. Then place the compass near the conducting wire and observe what will happen whenever we close the circuit and we open again, then close it. Then observe what happens to the compass. Okay, so I'll give you 3 minutes to perform this activity and show me your performance. Okay, time's up and let's proceed. Okay, so this is Hans Christian Urstead. He is the man responsible for the concept or for the relationship between current and magnets. So long before Hans Christian Ørsted experimented this idea that current or electricity and magnet is related or connected from one another, uh, scientists before really thought that current and magnet or electricity and magnetism is a different kind. But because of this man, he proved by means of experiment that a magnet and a current is really related from one another. So the activity earlier you do is actually the same experiment by Hans Christian Ørsted to prove that uh, electricity and magnetism is related. So what happens to that activity is that we run through a current in a wire. Whenever we close the circuit, the current will flow through the wire, and the current, as it moves through the wire, it creates a magnetic field. So it means to say that whenever we have electricity running through the wire, it produces a magnetic field, and that magnetic field is the same for that magnet. That's why whenever we close the circuit, the electrons will flow to the connecting wire, and that electrons will create a magnetic field, and it will deflect the needle of the compass because that needle is sensitive to the magnetic field, which is a magnet. So in that particular experiment, it proves that electricity and magnetism is very much related. So you could create a magnet out of electricity. Okay, so I do hope you get the main idea about electricity and magnetism. So that's it. It's the big picture of the whole thing about electricity and magnetism. So electricity and magnetism, again, they are very related from one another in the sense that we could create a magnetic field out of electricity. Okay, so during 1820, he discovered that electricity and magnetism are linked. He showed by experiment that an electric current flowing through a wire could move a nearby magnet. The discovery of this electromagnetism set the stage for the eventual development of our modern technology-based world. Now, it is very, very uh, tangible and feasible that this idea made our modern community to progress. So what I mean is that because of this idea, it makes us, it modernized the whole process, especially in the field of engineering. Application of this is that in our ATM card, it is, we have here a black strip, this one. So this uses an electromagnetism. This one is since sensitive to an electromagnetism. So whenever we put this to an ATM machine, we scan the code here hidden in this part using an electromagnetism, electromagnetic field. So aside from it, since we know that uh, electricity can create a magnet in the field of a magnet that can be turned on and off using electricity. So that is one of the big advantage of this idea. We could create a magnet that can be turned on and off using electricity. So before anything else, let us have first a little background about electricity. So electricity is the presence and flow of electric charge, specifically electrons. Using electricity, we can transfer energy in ways that allow us to do simple chores. Its best known form is the flow of electrons through conductors such as copper wires. So in general, when say electricity, it is the flow of electrons, and these electrons possess energy capable of transforming to another forms of energy. And this idea is very, very important. Okay, so we have here a diagram. As what you have noticed, we have here a battery. Now, from the negative terminal, the electrons will flow and then trans through the wire, and then whenever we have here a light bulb, it transfers the electrical energy to light energy. So some of the energy from the electrons will be converted to light energy, and the rest will just return to the battery. So that's how electricity works. And notice the direction of electrons. So electron starts from the negative terminal to a positive terminal. But in conventional flow, we have conventional flow because scientists at that time really thought that electrons flows from positive terminal to a negative terminal, but in reality electrons flow from a negative to positive. But for conventional, again, it is from positive to negative. Okay, now you must remember this because this would be helpful whenever you would take some exams. It's what we call the right hand rule. For you to be able to know the direction of the magnetic field, all you need to do is grab the wire like this. For example, uh, this is my wire. And this is the direction of electrons. Grab the wire with your finger and point this thumb to the direction of the current, and your fingers to the direction of the magnetic field. So it implies that if this is the direction of the current, so you just grab the wire and your fingers will curl, and this points to the direction of the magnetic field. So this is the right hand rule. Okay, so that is all about right hand rule. So again, a right hand rule is a very handy tool for you to know where is the magnetic field by just pointing out the direction of the current. Okay, so I guess for better understanding, for further understanding, it is best to have a demonstration of this. So let's go here, and I'm going to show you about first electricity. So here I have here a bench power supply. As you can see, I'll just turn this on, and this one is also a power supply. This one is a power supply, and this one is a bench power supply. Now the difference between the two is that this one is you could adjust the voltage, the ampere, and the wattage. Here, since this is just a DIY device, this is just intended for educational purposes, and do not use this one other than for educational purposes, because this is very dangerous. Now, as what you have noticed, all the devices and the components of this one exposed, and this might electrocute you. So don't ever try to make this one without the supervisory of an expert. But in general, this is just the same. Let's start. So electricity is just the flow of an electron. So electron is a charge. Whenever we have an electricity, what happens is that, for example, this one, this is a wire. Whenever we supply an electricity here, the electricity will just run through the wire back to the source. So let's go back here. Let's first use the power supply. So I'm going to set this one. I'm going to set this one into 12 voltage. So 12 volts or 12.5, and the ampere, going to set the ampere by 4 amperes. Okay, so we have 12.5 volts and we have 4 amperes. So as what you can see, whenever it produces spark because of electricity. Now, in general, we use electricity to convert the electrical energy into another forms of energy, just like light or heat. So this one I'm going to show you. We convert electrical energy into a light energy. So node or the negative charge, just place it here, and the positive charge here, and wait for it to turn. Okay, so again, once the circuit is complete, we transfer the electrical energy into a light energy. So when you say electricity is somewhat like we are just transforming energy from one form to another by means of uh, running charges to a circuit. Again, so that is all about electricity. It is just the flow of charges, specifically electrons, to a circuit. Okay, so I hope you understand electricity. That is the fundamental property of electricity, the flow of electrons in a conducting wire. Okay, so here again, this is an improvised power supply. Now I'm just going to show you how it works. So this is the switch, this is the transformer, this is the rectifier diode, and this is a filter capacitor. Now, as what you could notice, we have 0 and 1. So this is a modern type of switch. Now, most of us don't know what is the on and what is the off of this switch. The indicator of this one is that this is a binary number. Uh, in programming, we have ones and zeros in the computer. So 1 stands for true, while 0 stands for false. So when you say 0, it is off because it is false, and 1 is on because that is true. Okay, so once we press 1, it implies that in binary that is true, so it means it is on. So we turn on this one. Now the current will flow. Since this is an alternating current, the current will flow from a different direction, or one at a time, either from this direction and or that direction. And by the way, we have here the fuse in case that we have uh, a higher ampere. This prevents the whole circuit to be destroyed. And so what happens that whenever we have a higher amperes, this fuse will just melt, preventing the whole circuit to be destroyed. So let's start again. This is just the concept of electricity. We use electricity in a lot of things, to turn on lights, to produce sound, to produce heat, to cook, everything. So, and by the way, this power supply converts an AC current to a DC current by means of this diode. So we filter the current from AC to DC using this diode. This is a rectifier diode. This is the component responsible for converting an AC current to a DC current. Okay, so let's start. Now, again, this is just the same with the bench power supply, but this one is just a DIY. So the intention of this one is just for educational purposes, so that students will be acquainted with the different basic components of the power supply. So let's start. I just turn it on. Then we connect the positive and negative terminal. Now, for you to be able to know what is the negative terminal and the positive terminal of this one, see the filter capacitor. We have here an indication. So we have here a negative, so this implies that this terminal is negative since we have this indicator, and the other side is positive. Let's start. So we connect the two terminals so that we have a closed circuit for the electricity or electrons to flow in the circuit. Okay, so again, it is all about electricity, the moving of electrons in a conducting wire. So let's turn this off. Now I will going to test how much is the voltage output of this one and the amount of current produced by this device using our multimeter. So we're going to use multimeter to test the current voltage of the device. So just turn this one. So we select V for voltage. So here, kung makikita nyo. So we put this into voltage. Now let's go back here. So I already turned this on. Now we test. So this is again the negative terminal, and this one is the positive terminal. So put the probe negative to negative and positive to positive, and we look how much is the voltage output. So the voltage output of this device is approximately 15.8 volt. We test again. We change this one to amperes. So letter A stands for the current ampere. So we put the negative terminal to the negative and the positive to positive. And we test how much ampere. So we have 0.44 amperes. So that's how you use multimeter to test the amount of voltage and the amount of current in the device. I hope that short demonstration helps you to understand electricity. So electricity, again, it is just an energy that flows in a conducting wires because of the movement of electrons, and that energy can be converted to another forms of energy. So that is the good thing about electricity. So let's proceed. And by the way, we have very countless application of electricity, from the movement of your eyes, from the movement of your muscles, from the beating of your hearts. It uses electricity. So it is very, very, very important. So the concept of electricity is everywhere and its application is countless. So let's proceed to magnetism. So when you say magnetism, it is a phenomenon associated with magnetic fields, which arise from the motion of electric charges. This motion can take many forms. It can be an electric current in a conductor or charged particles moving through space, or it can be motion of an electron in an atomic orbit. Magnetism is also associated with elementary particles such as the electron that have property called spin. Now, in short, its definition is somewhat like fuzzy, it's very unclear, and it is not that understandable. So I'll just make it into more sense. So when you say magnetism, it is the property of the magnet. So in the property of the magnet, it's either attracts or repels. So in short, magnetism is somewhat like a force, and this force is caused by the movement or the spin of the charges within the atom. So that is what we call magnetism. Again, it is the force created by the spin of charges within the atom. And think of it as a force. That is what we call magnetism. And now, we have different types and shapes of magnet. And these are, we have a ring shape, disc, U-shape, bar. Okay, so all of this produces magnetic field, and this belongs to magnetism. Now aside from that, in our earlier activity, we know that the movement of an electron creates a magnetic field. In this diagram, we have here a battery. This battery is connected from end to end, from positive to negative, and we have here a nail. So we coil this wire in the nail, and whenever we have a closed circuit, it creates a magnetic field, or magnets. This becomes a magnet, so it attracted the clips here, paper clips. So the same of this, so we could make a magnet out of electricity. Again, for better understanding about this topic, I do believe that it is best to have a short demonstration of this one. Let's proceed to uh, magnets. So this is one of the main topic that we should discuss. So we have different types of magnets. So in general, we have two general types of magnet. We have the permanent magnet. This is an example of permanent magnet, and a temporary magnet. So meaning, for permanent magnet, it is permanent. Its magnetic property is remains for a longer period of time. for a temporary magnet, those are materials that exhibit a little amount of magnetic property for a short period of time. Now, uh, based on our topic, the property of magnet is that it has two properties. It could attract and it could repel. So whenever we have north to north, or this one, let me use this one. Okay, so whenever we have two magnets, it has a north and south poles. So here they have the same polarity, so it could be north to north or south to south. Now if I flip this one, they repel each other. The property of magnet is that it either repel or attract. So it attracts whenever they are unlike polarities, and they will repel whenever they have the same polarity. So in physics, for magnets, there are only two types of polarities. It could be the north and the south poles for magnets. So here they repel, so you could feel that there is somewhat like a force resisting for them to be combined. So it's very hard to push them together whenever they are like or the same poles or the same polarity. But whenever I flip this one, so there's somewhat like a force, attractive force, that these two magnets wants to be combined. Okay. Okay. So that is the basic property of magnets. Either it could repel or it could attract. However, these magnets will mostly attract metals, just like this one, it will attract metals, or this one will attract because this is a metal, or this one can attract metals. But bear in mind that not all metals is attracted to a magnet. I'll show you one. Wait for a minute. Now, again, I told you that magnets attract most of the metal, just like this one. This is a metal, so it will be attracted by the magnet. But bear in mind that not all metals is attracted to magnet, just like this one. It is not attracted to magnets. So whenever I place the magnet here, it will not attract. So not all materials or not all metals is attracted to magnet. And a good example of this is aluminum. So this is an aluminum, and aluminum is not attracted to magnet even though it is metal. Okay, so that is all about magnets. Now, in our topic, we said that we could produce magnet out of electricity, and I'm going to show you how to produce magnet using an electricity. Okay, so the first component that we should have is that we must have a loop of wires. So this is just a mere wire. So I just loop this one for, if I'm not mistaken, I loop this one by 200 times. So, and the other one is 100 times. So the difference between the two is that whenever you have plenty of loops, the magnetic property of this one becomes much higher compared to the smaller number of loops. So let's start. So whenever we have here a loop, when we don't initially supply this with an electricity, it will never attract this metal. So again, this is prior from supplying an electricity. This piece of metal, when is not attracted to this one. However, whenever we place electricity, so let me just turn this on. We have here our bench power supply. So we use this one to supply electricity here and make this one as a magnet. So 12.5 volts and the ampere is 4 amperes. So 4 amperes. So we connect. So either of the side is a negative or positive. So this one, whenever we supply current here, what happens that the current will run through the loop. And what happens that whenever the current run through the loops, it will make or it produces a magnetic field, and this magnetic field is the same with that of a magnet. So it means that whenever we have your current running through the loop, this loop creates a magnetic field which is the same with this one. So I'll show you. So we have here a piece of metal and this will be attracted. So again, this we have already here a magnetic field, and see this one. I'll place this one in between and look how it sticks to the loop. And that is how you produce uh, a magnet out of an electricity. So we could somehow make a magnet out of electricity. Okay, let's proceed to electric motor and electric generator. Now, I do believe that all of you know what is an electric motor and an electric generator, but the problem is we don't know what is happening and how is it possible for these devices to work. So when you say an electric motor, electric motor is a device. This is a device used to convert electricity into a mechanical energy. Opposite to that is an electric generator. So an electric motor, it just converts the electricity into a mechanical energy to do work. And the opposite is the electric generator, because the electric generator uses mechanical energy and convert it to electrical energy. So they operate using principles of electromagnetism, which shows that force is applied when an electric current is present in a magnetic field, and this force creates a torque on a loop wire present in the magnetic field, which causes the motor to spin and perform useful work. Okay, so I guess it is best to explain this one with a diagram. So we have here a diagram. This is an example of a simple electric motor. So here we have here a battery, and this battery is connected to this loop. So that is a loop, and we have a permanent magnet on both sides. So what happens here is that whenever we have here a current running to the loop, so the current will move in this loop and it goes back to the battery. Now, uh, we know that whenever there is a current running to a wire, it creates a magnetic field. So when we grab our thumb, our hands and use it as the right hand rule to know where is the direction of the magnetic field, we just grab the wire here, and this thumb points to the direction of the current while our fingers points to the direction of the magnetic field. So what happens here is that it implies that the current is moving in that direction, so the magnetic field is curling. So our north here is up and our south here is on the bottom of the loop. Now we could also use this kind of right hand rule. So this is Fleming's right hand rule. So using this Fleming's right hand rule, we could know where is the rotation of what is the rotation of this loop. So just like this, So the three of this one must be perpendicular from one another. So these thumbs point to the force. This pointer finger points to the direction of the current, while this one, our middle finger, points to the direction of the magnetic field. Now in our diagram, uh, the movement or direction of the direction of the current is this one going to that, while the direction of the magnetic field of the two permanent magnets, since in north and south pole it starts from north then to south, so what would happen is that we turn this like that. This is the direction of uh, the current, the direction of the magnetic field of the magnet. So it implies that the force here is going down. So that's why you see the arrow here is going down. Now, when it reaches the other side, so we have here again the motion of the current. The direction of the magnetic field here is constant, and the force in this case going up. So what would happen is that we have a force down and a force up. That's why it will rotate. So the direction is like that. So it will create a rotational effect. That's how electric motor works. And this Fleming's right hand rule is very, very handy when you encounter such kind of problems. I hope you get the idea. Okay, so uh, this is again a simple electric motor. So though it is much complex to this one, but the idea is the same, up to more complex device. But still the idea is there. Simple idea, we just make this into a more creative and complex one to, to, to achieve more efficient work. So I do believe that to have a better understanding, further understand this concept, let us have a demonstration of this idea. So now I'm going to show you how electric motor works. So an electric motor is a device that converts electrical energy to a mechanical energy. So what it does is that we supply electricity in that device so that it could perform works from simple tasks to more complicated one. So that is electric motor works. So we have here a coil of wires again. So whenever we supply an electricity here, this loop will create a magnetic field the same of that of the magnet. So we have here a magnets below this wire loop. So whenever we run a current here, what happens is that this creates a magnetic field and interacts with that of the magnetic fields of that the magnets. And what happens that it will rotates because of the interaction of the magnetic field caused by the loop and the magnetic field caused by the magnet. So it will interact from another and it will create a rotational effect. That is how electric motor works. Now I will show you uh, with this experiment that this device will make or will rotate by using an electricity. So we connect both terminals to the connecting wire, and we have here our power supply or the source of our current. I set this one to 10 volts and the ampere here is 2.5. So we connect the positive and negative terminals to the device and it creates a rotational effect. Okay, so this last device is what we call um, electric generator. This is the idea of how electricity is being produced from the main source, which is the power plant, to a substation, from a substation to uh, households of the communities. So again, this is the idea of how electricity is being produced from the source up to the consumers. So uh, this is an example of an electric generator. So if this device, if this one electric motor converts electrical energy to mechanical energy, an electric generator do the opposite one. It converts mechanical energy to an electrical energy by using an electric motor. So we still use an electric motor, but in this case we convert the mechanical energy into an electrical energy using the electric motor. So here we need to apply a mechanical energy or work to do the rotation of the electric motor, and this electric motor will collect the magnetic flux of the magnet and convert that one to electricity. So here I tried to light this bulb using this simple electric generator. Okay, so as what you have noticed, we connect these two light bulbs to this uh, simple dynamo or electric motor, and we rotate this one using this handle to move this uh, piece of metal which is connected. So the faster you the more electricity is produced. So this is how a generator works. So you need an external force, mechanical energy, to do the work to convert it to an electrical energy. In power plant, this is the concept happens there. So the power plant, for example, in Maria Cristina Falls, they use the falls, since it is the water is falling down, so it has an energy, mechanical energy. So we have here, we convert this one as a turbine. So whenever that water falls down and it hits the turbine, so what happens that it will move or it will rotate. So that rotation creates the movement of this device. Whenever this moves, it creates an electricity. So that's how an electric plant works. Or for example, in a coal industry, so we have here a plant that uses steam. So they use coal, so they heat the water. So whenever that water is heat, what happens that it will become a steam. So that steam uh, will make the turbines move. So that steam will move this one, make this device rotates, and then it will produce an electricity. So that's how we harness electricity. So these are the basic idea of how electricity is being produced and electric motors works. Thank you. Okay, so thank you so much. That is all about electricity and magnetism. And for your assessment, please go to this link and answer the required questions there. Okay, so fill in this form and submit your answer. I'll give you about uh, 3 minutes to answer that question. Okay, thank you so much. And now for your assignment, please proceed to this link and fill in the required fields in the form. Okay, this is for your assignment. Just take a screenshot of your device. So I guess that's all for today. I do hope you understand the basic fundamental ideas about electricity and magnetism. So that is the fundamentals. So if you would become a future engineers, you would still have to rely on these fundamental ideas for you to be able to create something more efficient and more affordable devices in the near future. And I hope that you utilize these ideas of physics for the benefit of mankind, not to intentionally harm uh, mankind. So again, bear in mind that these ideas must be utilized properly, okay, for the benefit of everyone. Thank you.